The atom, as we know, is made up of a dense core known as the nucleus, which contains the protons, which hold a positive charge, and neutrons, which hold a neutral charge. As such, the nucleus of an atom is positively charged. Much further out from the nucleus is the electron cloud, which contains the negatively charged electrons, which are super tiny in comparison to the protons and neutrons. Now, the amount of positive charge from the nucleus equals the amount of negative charge from the electrons, which makes the entire atom neutral. Since the proton and neutron are of similar mass, this sphere represents their relative size. An electron would be this size in comparison, about 1 pixel. Therefore, the entire mass of an atom relies heavily on the nucleus. It's like if you shaved your eyebrows, you would not necessarily lose weight because the hairs are insignificant in comparison to the rest of your body. The atomic number is used to identify the element. Now, this represents the proton number. Hence, this also represents the electron number. Now, the atomic mass represents the total mass of protons and neutrons. You're probably thinking why it's not a whole number. If we focus on hydrogen, hydrogen exists as isotopes. That is, atoms of one element that have different number of neutrons in their nuclei. In this case, the 3 isotopes of hydrogen are protium, deuterium, and tritium. All have the same number of protons and electrons, but differ by the number of neutrons. The superscript number shows the mass number, that is the protons plus the neutrons, and the subscript shows the number, or the atomic number, that's the proton number. So the atomic mass is the average of all those isotopes. In fact, this number tells us that the majority of the isotopes of hydrogen are protium because the number is closest to this isotope.